Good morning to all of you. In the previous lecture, we have to discuss about the design of the DC machine, the construction of the DC machine, the implementation of DC machine, and authentication of the DC machine. Now, in this session, we have to start for the next topic, factor affecting of the main dimension of the DC machine. Okay. So today's our topic is the factor affecting the main dimension of the DC machine. If you can design any DC machine or AC machine, which factors are really very important for the dimension study. One is the air ratios is one of the important points, peripheral speed, moment of inertia, and voltage. First, let me discuss about the air ratio. The air ratio is this is the important terms in design of DC machine. It is the important terms of the design of the DC machine for the minimum cost L by ratio is 1.5 to 2 for the good efficiency. If you can get a better efficiency for your machine, so the L by ratio is between 1.5 to 2. If more than 2, the efficiency is really very poor, and if one less than 1.5, so is also bad efficiency for your machine. So it is the most important for your peripheral ratios. L by ratio is 1.5 to 2 for the efficiency is better for your machine. Second point is the peripheral speed. Peripheral speed. So what is the peripheral speed? So peripheral speed the effect on the overheating the portion of the armature winding which is outside the slot having the no support. So the VE is limited to 30 microsecond. The equation is V is equal to 5. 30 microsecond. So what is the value of VA? Peripheral speed is greater than 30 microsecond. So your friction is really very low. So if friction is low, so automatically your machine is vibration is very low. So machine speed is very better and your efficiency is also good for your machine. Third point is the moment of inertia. What is the moment of inertia? So generally the moment of inertia is proportional to the mi proportional to d square for this 4L. That is the equation. Mi is directly proportional to d4L. Yeah? So the diameter should made as small as possible for the machine used for the control system applications. Right? Fourth point is the voltage between adjustment. Voltage between adjustment segment. So what is the voltage? The maximum core length L. Maximum core length L is decided by the maximum voltage that can be allowed between adjustment segments. That is the equation of the adjustment segments. Right? So TC, that is the TC. What is the TC? That the TC is equal to turns per coil, and G is equal to magnetic flux density. So that is there are the 4 main parts for you can design your DC machine for the main dimensions. You can create the diameter, length, and these 4 parts will be very important for your factor affecting of the main dimension. So let's start for the new topic. Factor affecting of the specific magnetic loading. I don't know what is the specific magnetic loading. VAV. VAV is the magnetic flux density in the DC machine. But in the framework, that is the specific magnetic loading. If we can design the parameters of the magnetic specific magnetic loading, to which factor will be very effective in this topic? So first is flux density in T. It means the flux density, frequency, size of machine, and voltage. That is the main 4 parts. So 4 types. So let's have discuss point number 1, flux density in T. Right? Flux density in T, the flux density in to the portions will also be high, and the cross the limit of 2.2 Weber per meter square. It means the flux density through ocean is less than 2.2 Weber square, right? If your flux density is more than 2.2 Weber square, so what is the effect? So that is the Moore effect. Iron losses will be increased. Copper losses is also increased. Cost of machine is also increased. Very, very, very our disadvantage for our machine. So what is the importance of the flux density? If the flux density is really very important parameter for the magnetic specific magnetic loading VEV. Why? Because if iron losses is high, copper losses is high, and cost of machine is really very high, so after all your machine is totally huh? Therefore, your machine the flux density of the teeth is designed of the portion of less than 2.2 Weber per meter square. Right? So second point is the frequency. So what is the importance of frequency? What is the main importance parameter regarding of the specific magnetic loading for the frequency? So frequency depends upon the speed. Right? Frequency depends upon the speed. What is the equation? F is equal to Pn by 2. Here P is indicated to pole, correct? And N is indicated to speed divided by 2. If if air gap flux density is assumed to higher, if you can assume the air gap flux density is assumed to higher, then iron losses is equal to, for example, hysteresis loss plus eddy current loss will be increased and the machine will be less efficient. You know that if air gap is increased, so what is the difference? Hysteresis losses and eddy current losses will be increased. After all, these two losses will be increased. The efficiency of all the machine is really very decreased, right? So if efficiency is reduced for the machine, then the maintenance cost of a machine is really very high. For higher frequency of the machine, the VAV should be less than selected less. Size of machine. If machine size high, then the cost machine is very high. It's a simple thing, right? See here, show this diagram. The armature diameter D in meter, right? If your diameter should be checked and the specific magnetic loading, so what is the effect of the cost, right? If your output will be same, but if your machine design is really very very big, what is the difference? Your machine cost is really very high as compared to your output. So it's really very important for your size depends on your output. Fourth point is the voltage. What is the importance of voltage for the specific magnetic loading? For high voltage machine, space the required is more due to more insulations provide the insulation occurring more space and hence the space for iron losses. Hence, the more flux density VAV cannot be provided. Right? The the value of DAV, the value of VAV is generally taken between 0.5 to 0.75 Weber per meter square. The flux density in the air gap Vg between 0.64 to 1.1 Weber per meter square. Correct? Similarly, for the another topic is the factor affecting specific electric loading. In the previous topic, we have to discuss the specific magnetic loading, but in this session, we have to discuss our specific electric loading. In the specific electric loading, we have to discuss our total 4 points. One is the temperature risk, second is the speed, voltage, size of machine, armature reactions, commutations. This type of 6 parameters will be very effective in the specific electric loading. Okay? So we have to discuss the first point, temperature risk. So what is the important parameters and what is the important factor affecting regarding the specific electric loading using the temperature range. Right? If AC whose specific electric loading is taken more than heat production is more, which is the increase the temperature. If AC is more, means the copper use is very more. The large size and more insulation heat distributions become the laser. On the other hand, also if the conductor size is less, the surface area or heat distributed is less. This is also not correct. Hence, AC is to be properly selected. So what is the important parameter in the temperature is? So temperature is, it means that your DC motor or DC generator is the one of the rotating part. It's not a static part. Right? It's a rotating part. In the rotating part, if the machine is rotated, your temperature is automatically generated. But if your machine is not properly fitted, yeah, whatever, the temperature will be increased, the copper losses will be burned. Right? So it's a really very important. Second point is speed. For high speed machine, the high value of AC, right, can be taken. Is uh, this is because higher speed ventilations or is observed better and dissipations of the heat effective. For the high machines, the speed is really very high. Right? Voltage for the higher voltage, less AC is the fusion. This is because the higher voltage means the higher value of the insulation, which is the turn occur of the more space. Right? So compressively less space availability for the copper and iron. If iron is less than, there is a limit of VG, hence for the high voltage machine less of AC. Right? Size of machine it's already discussed in the specific magnetic loading. Same similarly for apply for the specific electrical loading. The mechanical dimensions for big size of the machines allow the more iron and copper parts. Hence, the machine cost is really very big. Right? If you can design your machine in very big size, so the iron part and copper part will be used in large quantities. So if large quantity will be used, so what happens? What's your point? The cost is really very high. Now, armature reaction. Large electric loading means large ampere turn. Large ampere turns means more destruction due to the armature reaction. Hence, the armature reactions limit the selection of AC to be compensates the effect of the armature. The reactions fill the armature turns to be increased and hence this lead to more cost of your machine. What is the commutation? The commutations, if AC is select more, then the reactance voltage is increased. The tipper the slot are not to be used in the product sparking and brushes. The sparking and brush to poor the communications. Hence, there is a limit for the selection of specific electric loading. Now, so we have to start next sessions for the example regarding this topic. Thank you.